What is function template? How function template can be declared and used in C++. Templates can be used when same operations to be performed on different data types. It enables to define a generic function or class that operates on generic data types instead of creating a separate function or a class for each type. This approach of writing program is known as generic programming. Advantage of using template is that it reduces the source code size and increases code flexibility. Function templates. Function templates are functions that can operate with generic types such that the functionality can be adapted to more than one type or class without repeating the entire code for each type. Function template uses template parameters to represent the generic type. Defining function template. The format for declaring function template starts with the keyword template followed by a less than and greater than symbol. Within the less than and greater than symbol, we have to use either the keyword class or type name followed by a valid C++ identifier. This identifier acts as the template parameter, followed by either function declaration or function definition. So while we are declaring a function template, we have to use the keyword template followed by either the keyword class or type name and valid C++ identifier that represent the template parameters followed by a function declaration or function definition for the template. Use either the keyword class or type name followed by a valid C++ identifier to represent the template parameter. Template keyword informs the compiler that a template is being declared. When a template is defined, it does not actually define a function. Rather, it provides a blueprint for generating a set of functions. Template statement must be specified in both the declaration and definition of the function template. Calling function template. When the function template is called with the actual data type, the compiler generates a specific version of the function template for that data type, and this process is known as template instantiation. Function definition created from template instantiation is known as specialization. There are two types of template instantiation. First one, implicit instantiation. When the function template is called, the template parameters is dynamically determined by the compiler according to the parameters passed. Second one, explicit instantiation. During the function template call, the template parameter specific type can be mentioned as with the function name followed by a less than and greater than symbol. Within the symbol, we have to mention the actual data type value followed by set of parameter values. So while a template function is getting called, in explicit instantiation, after the function name, we have to mention the actual data type between less than and greater than symbol. Example to create a function template that returns the greatest of two generic types. either the greatest of two integers or greatest of two float values. For writing this program, we start with a keyword template followed by a less than and greater than symbol, and within that we are using the keyword class followed by an identifier for the data type. So we are using type 1 as the identifier for the new data type. Type 1 is template parameter name that is not yet specified but can be used as regular type. In the template function definition, we are using the function template name as getMax. It takes two parameters a and b of type 1. The return data type of the getMax function is also type 1 because the getMax function will return either the value a or b depending upon whether a or b which one is the greatest number. So by using a conditional operator, we are checking whether a is greater than b. If a is greater than b, we return the value a, otherwise we return the value b. GetMax is the function template. Now we are writing the main method. Inside the main method, first we declare two integer value x1 and y1 which is initialized with the value 4 and minus 10. Next, we have declared two float values x2 and y2 which is initialized by 5.4 and 3.2. Then after that, we are calling the function template getMax twice. During the first call getMax, we are passing the parameter. The data type value for type 1 is passed as int, and the value of a and b is x1 and y1. So here type 1 will be integer type. So we are passing a and b which is x1 and y1, both are of integer type. The second function call of getMax, we are passing the type as float. So type 1 will take the value as float and a and b will take the value x2 and y2 which are of float type. And by using a cout statement, we are displaying the result of z1 and z2. So in this case, getMax function is called by using explicit instantiation, wherein which we have mentioned the data type for type 1 in the first function call as int, in the second function call type 1 is float. GetMax is called twice, first with the arguments of type int and second with arguments of type float. So in the first getMax, the data type for type 1 is int, and in the second function called getMax, the data type value for type 1 is float. This getMax includes only one template parameter. Calling the function template with two objects of different types as arguments is invalid. For example, if you are writing getMax and we are passing two types, int, float, and two values, 4 of integer and 4.5 as float, this gives a syntax error because type 1 can take at a time only one type. Type 1 can be int or a float.